Welcome to Multiple Choice Monday number 8. So this was an enthalpy change question and the correct answer was D. So how did we get there? Standard enthalpy change of formation is something that we need to be able to write an equation for and also a definition. It's often written as delta FH or delta HF, and it's given as the enthalpy change when 1 mole, and that's really important in all our enthalpy change definitions. Every single one of them involves 1 mole of something doing something. And it's 1 mole of a compound. People often forget that bit. Is formed from elements in standard state. So what does that mean for this question? We can write an equation for the delta H formation of PCl5. When you're writing a delta H formation equation, I recommend that you put the compound on the right hand side, and when we know it's a gas because we're told that in the question, and then you put the elements on the left hand side. So P is just going to be solid as given in this question, and we need to make our gases diatomic. So chlorine is Cl2. And chlorine goes around as a diatomic molecule, but I need 5 chlorine atoms for my phosphorus. Now, if I'm writing the enthalpy change of formation equation, then I really want to make sure it's for 1 mole. So that means that I need 2.5 moles of chlorine, which I've not left enough space for. So 2.5 moles of Cl2 makes 1 mole of PCl5. Do not be tempted to double up that equation because this is a standard enthalpy change. It has a standard definition, making 1 mole of a compound. So now that I've done that, and I know that the delta H for that reaction has been given in a question, so in that direction it's -443. Now we should know that if we reverse a reaction, if the forward reaction is exothermic, the backwards reaction is endothermic, and because you are breaking the same bonds that you were making and vice versa, it will be exactly the same value as +443 kilojoules per mole. However, the reaction given in the question is not only reversed but also times by 2. 2PCl5 goes to 2P and 5 Cl2s, which means we are going to get twice as much energy needed to be put in. So the enthalpy change ends up being double and the reverse sign. So if you want more questions on enthalpy changes, I've got loads of stuff and more videos on Hess cycles, rearranging enthalpy equations on my website, and you can follow me on Instagram and Facebook for more A-level chemistry tips and revision materials.